You are listening to RudolfSteinerAudio.com. As well, you can hear these podcasts at RudolfSteiner.podbean.com. Please consider becoming a patron. There are two publishing houses, SteinerBooks.org and RudolfSteinerPress.com, which are the sole publishers of Steiner into English and have given me permission to do these recordings. Please consider patronizing them as well. This is a reading of Collected Works, Volume 164 by Rudolf Steiner, 11 lectures, entitled The Value of Thinking for a Cognition that Satisfies the Human Being. It is in 3 sections, and I have been just considering the lectures all as one set. And this is the last lecture, Lecture 11. It's in the Part 3 of the book entitled Episodic Observations about Space, Time, and Movement, and that is the title of this 11th and last lecture. Translated by Christian von Arnim, and this is given in Dornach on the 20th of August, 1915. I thought that at most a dozen people would be here today, and I wanted to say something, as will indeed happen, that is quite episodic, something that does not belong at all to our other reflections, but which can be important for some, who can live their way into the matter a little, in order to assess some of the things that play a role in relation to certain notions of space and time and movement in time. There are theoretical physicists today who are of the opinion that a profound revolution is taking place with regard to the simplest concepts of the world. Among these simple concepts of the world that underlie theoretical physics, we want to look a little bit today at something that relates to time, space, and movement. This will provide the basis for more extensive observations to be made in the near future, which can lead us deeper into what is aimed for in fundamental physical observations at the present time in particular. You will certainly all have heard that what is called the theory of relativity in modern physics is now gaining ground. The theory of relativity, there are also various nuances, is advocated today by countless theoretical physicists. It is hoped that it will bring about a complete change in all the concepts that physicists have hitherto accepted as correct when they have made fundamental theoretical observations, and which essentially go back to Newton. Now, the more recent theoretical physicists of today believe that all these Newtonian concepts, which were still accepted as quite incontrovertible in our student days, must undergo a revolution. Indeed, that to a certain extent, the whole theoretical basis of physics, as it has been believed and is still believed, is actually wrong. Now, why I have to relate the observations I am about to make to this newly emerging theory of relativity, that will become clear later. So that what I have to say does not remain completely incomprehensible, I would like to start from very simple elementary concepts in order to demonstrate to you, through them, what kind of idea we can associate with the concept of time. Let's start, as I said, from very elementary things. Let us assume that some object that I will call A, a rolling ball or the like, is moving in a direction that I want to indicate by this line. So A moves along the straight line in the direction of B. Now you all know that the distance, the length of the path, which such a moving object covers in 1 second, is called the velocity. So let's assume that A gets here to A sub 1 in 1 second. Then in physics, this distance from A to A sub 1 would be called the velocity and labeled c. And if we further assume that the moving object continues to move through the following seconds, then if it were to perform a uniform movement, and this is the only movement we want to talk about, it would be at A sub 2 at the end of the second second, where A sub 1 equals A sub 1, A sub 2. That is to say, with the same velocity c, the moving object goes from A sub 1 to A sub 2 in the second second, from A sub 2 to A sub 3 in the third second, from A sub 3 to A sub 4 in the fourth second, and so on. Let us now assume that we observe this movement over a certain period of time, and that our moving object travels a certain distance. Let us assume 2 A sub 5. Then, if this moving object has rolled from A to A sub 5, the section of space, which we consider here in its one dimension, is called the distance. so that a to a sub 5 is the distance it has traveled. C is the velocity. The distance is referred to as s. And we say the moving object A has traveled s at velocity c in a certain time. In this case, 5 seconds. This elapsed time is referred to as t. Now, there is a certain relationship between distance, time, and velocity. The simplest relationship that has been found is what we would say here. S, the distance, is 5 times from A to A sub 5. That is, once the distance A to A sub 1 times 5, that is 5 seconds. So that is the time. So we have to multiply what we call the velocity, this section A sub 1, by 5. Then we get the distance S equals c times t. Distance equals velocity times time. So there are 3 concepts in this formula: S, C, T. Now you know that an infinite amount has been written about time by a number of philosophers, mathematicians, and also theoretical mechanics. People believe they have an idea, a concept of time. But if they had to explain and think about what they understand by time, everyone would very soon realize that they have no real idea of this concept of time, which is one of the most common concepts used in mechanics. In order to be able to study something about the concept of time, let us stick to this formula, which at first places the concept of time in a uniform rectilinear movement. But even though this formula can be found in every physics book, in physics it is surrounded by a whole lot of, I don't want to say ambiguities, but by a lack of clarity, by little will to go deeper into the matter. And this stems in particular from the fact that in our schools, the teaching of something that we all learn does not teach us certain distinctions, which are, however, important if we want to arrive at more precise concepts in a certain direction. In our schools, we learn to talk about 4 types of calculation: addition, subtraction, multiplication, and division. But with division, I don't think we are often made aware that there are actually 2 totally different things in the ordinary calculating operation. Let me show you this in a very simple way. Let us assume we have an ordinary apple and divide it. We can divide it into 5 parts, into 10 parts, and so on. Then, when we have divided it, we get a certain part of the apple. If we want to share out the pieces, then what we share out is a piece of the apple. We are indeed performing a division here. I shall write it as a fraction, because that is the same as a division. I can say an apple is divided, let's say, into 10 parts. Then we get 1/10 of an apple as a result. Now take a look at what I have written on the blackboard. In the numerator, or dividend, we have a quality, something tangible. In the divisor, or denominator, we have nothing tangible but a mere number. 10 is just a number here. And in the quotient, we again have something tangible, 1/10 of an apple. This situation does not change if we share 20 apples instead of 1. Let's say we divide 20 apples by 10. So instead of 1/10 of an apple, we get 2 apples. The 20 apples are again something tangible. Below is just the number. And as a quotient, we again get something tangible. That is a division. But dividing can still have a completely different meaning. I can have 20 apples at the top in the dividend, but at the bottom as the denominator, or divisor, say 2 apples. Then I have something tangible above and below. What do I get as a result? Then I don't get something tangible as a result, but I find out how often 2 apples are contained in 20 apples. I get 10. That is, I get a number. Again, I'm dealing with a division, but this one now has a completely different meaning from the division in the first case. In the first case, I divide something tangible and get something else tangible. In the second case, I don't divide at all, but set myself the task of investigating how often something tangible is contained in something else tangible, and that gives me a number. So we can say, division is not always dividing, but there are two types of division that are strictly different from each other. So when teaching, we should always explain that there are two types of division. In the first case, my task is to explore what results when we divide something. In the second, the task is to find out how often something tangible is contained in something tangible of the same kind. They have to be of the same kind, because of course you cannot ask how often 2 apples are contained in 20 pears, and then we get a number. This must be taken into account when studying the formula S equals C times T. Now, this formula can also be written differently. I don't always need to search for S. I can also search for C or T. Then the formula changes. If I look for C, I get it by dividing S by T. By dividing the whole space by T, I get the space that has been traversed in 5 seconds divided by 5. That is the velocity c. c equals s over t. But equally, you can get t, the time. Suppose you divide s by c. If you ask, how often is the path of 1 second contained in the whole path? It is contained 5 times. That's where you get the time, t equals s over c. Let us take a closer look at these formulas. Let's take the second one first and compare. S, that's the distance here, the length a to a sub 5. That's what we have in the numerator. Here in the denominator we have c. What is c? Well, that's the distance in a second. These are distances. S is a distance, c is a distance. What form of division does this resemble? Well, that resembles this form. 20 apples divided by 2 apples equals 10. Here in the numerator you have apples, and here in the denominator you have apples. Here in the numerator of s over c, you have distance, and here in the denominator you have distance. What then has to be there in front? Just a number. That is, t results in our physics considerations as nothing other than a number. For if I regard s and c as distances, that is, as something tangible, both are distances or a part of a distance. Then, by nature of the division, time t can only figure as a number. Just as the number 10, 20 apples divided by 2 apples equals 10, is a number and nothing less or more. So in this division, t, time, cannot be anything other than a number. You can also take the form of division, 1 apple divided by 10 equals 1/10 of an apple. Then, this resembles the formula c equals s over t. If, on the other hand, something tangible is divided by something tangible, what must result? A number like here, t equals s over c, where we are dealing with a mere number with t. That is, both formulas indicate that insofar as we stop at physics, we get nothing but a number for time, depending on the nature of the division. Namely, here 20 apples divided by 2 apples equals 10 is a number that refers to apples and shows how often 2 apples are contained in 20 apples. And here with time, s over c equals t, is a number that shows how often speed is contained in space. Now, probably none of you will see something tangible in the number as such. If you give any boy or girl not 3 apples but only the number 3, they will not be full. So in the number we cannot see something tangible, but rather a mere abstraction, something that merely indicates relationships in the outer world, as it were. From this observation you can see that time itself slips out of our hands through physical observation. It shrinks down to a mere number for us. We can no more philosophize about time than we can philosophize about number. That is, it has been reduced to the conception of a number. That is also why we cannot find time in things, no matter how long we keep searching, because it only appears as a number. What is this related to? Well, I don't think a boy or a girl needs to be very old to give an answer that comes from a healthy feeling when you ask, what interests you, the apples or the number? Certainly someone could use sophistry and say, I am interested in the number because I prefer 8 apples to 6. But that is only because 8 apples are more than 6. So the number is not what this is about at all. It is about the apples, the tangible thing. But it follows from this that we must stick to the tangible in the first place, and not to the number when we speak of time, space, and velocity. And if we now consider the tangible, then time is discounted from the outset. That is, it is a number and not tangible. So you will be able to say to yourself, we have S, the space, the section of space that our moving object passes through. If it continues to roll, it can pass through much, much more space. After all, space is something tangible outside. But that's not what matters in the first instance, because you can think of space as going on and on. But something else has a lot to do with what matters to us, which is C. Because how A passes through space depends entirely on whether it passes along, say, 20 or 25 or 50 centimeters, and so on in a second. And again, how much it passes along depends on how fast it runs. But how fast it runs, that's within it. That's intrinsic to it. And the whole process in general depends on that which is intrinsic to the moving object. So it is the velocity of the moving object that matters. It belongs to the moving object as such. It is an inner quality of the moving object. And when we look at the world, insofar as we look at it in terms of mechanical processes, then when we speak of reality, we must speak of the inner velocity of bodies or atoms or molecules. And the whole process forces us to speak of the inner velocity as belonging to things, just as the red color belongs to the rose. So, the fundamental concept is velocity. This is what matters. It follows that we must not adhere to the formula which has C here, C equals S over T, and must not believe that with space and time we have anything particularly real. But what is real in objects is velocity, not time. Time, in turn, is only abstracted from the concept of velocity because things have different velocities. If we look at the different velocities and want to reduce them to a common factor, we get the concept of time. This is an abstraction, just as the generic term apple is an abstraction, and only the particular, the concrete apple is real. So if we address the mechanically real nature of things, we must address velocity, and not think that we can put the concept of time to the fore. This is the great mistake that is made everywhere in physics, that no attention is paid to the fact that we must start from the velocity that is intrinsic to things, that belongs to them as life belongs to living bodies. So keep this in mind, my dear friends. Not time, but velocity is what must underlie mechanics. You might now say that these are quibbles, making these distinctions. They are not quibbles, but these things are fundamentally important for the understanding of certain conditions of reality, and I want to point out something to you right away that shows how fundamentally important they are. In the various discussions about the theory of relativity, people were concerned precisely with coming to terms with the concept of time and the concept of velocity. Now, I will use 2 speculations to show you the way certain people think, how they formulate their thinking when they talk about time and velocity. Here I must introduce you to a curious personality, Mr. Luhmann, who plays a certain role in the theory of relativity. What kind of a curious gentleman is he? Well, you see, this is I would like to say, imaginary acquaintance that Flammarion has made. This Mr. Lumen has a very strange ability, which we can make clear to ourselves in something like the following way. You all know from your physics lessons that light has a certain speed. It travels 300,000 kilometers per second, c. That is, everything that is an intrinsic mechanical part of light, according to our understanding, is a speed of 300,000 kilometers per second. Let us assume, for example, that this is the Earth, and that from the objects and occurrences that happen on Earth, a ray of light travels out into space. Bracket was indicated diagrammatically on the blackboard, close bracket, and people say, after all, because the light travels out, we see the things. Let us now assume the following. We have here this somewhat abstract mathematics and physics lesson. And let's say, from 3 to 4 o'clock there was a eurythmy lesson. From all of this, light travels out into space, and you can observe from outside what is happening here. And since light travels at a speed of 300,000 kilometers per second, what happened here this afternoon between 3 and 4 o'clock also traveled out into space at a speed of 300,000 kilometers per second, so that if you imagine an observer who is 300,000 kilometers away, they will only see what is happening here on Earth after 1 second. Now Flammarion assumes that this Mr. Lumen is hurtling out into space even faster than light, namely at a speed of 400,000 kilometers per second. What will be the consequence of this? He will continually overtake the light, because after the light has traveled a second, he is already 100,000 kilometers further away, and he must, as he hurtles out and looks back, arrive at the disclosures of the light, where he sees what has happened here, now, and between 3 and 4 o'clock. But since he not only catches up with the light but overtakes it, it must follow that he does not first perceive the eurythmy session, and then our session, but everything the other way round. First the end, and then that which came earlier. It's a strange spectacle that this Mr. Lumen experiences. He sees everything in such a way that he first sees the end and then the beginning, because he is overtaking the light. Such ideas have, as I said, played a certain role precisely in the discussions about the theory of relativity. I would like to present another conception to you, which also played a certain role and which was developed by the naturalist Bayer. He said to himself, we can imagine that a person lives through their life not in about 70 or 80 years, but in 70 or 80 seconds. Their pulse would simply have to beat so much faster that a year would be contained in 1 second. This could cause the human being to be not even like a one-day mayfly, but like a 70-second creature, if only their pulse beat at a correspondingly fast rate. What would be the consequence? Such a person would go through incredible things in 70 seconds. If, for example, they looked at a plant that has remained true to its species, they would never come to the conclusion that a plant grows out of the earth, but they would come to the conclusion that plants are eternal entities. So such a person would relate to the world quite differently, simply in that the speed of their life should be thought to be magnified to the same degree as the speed of their pulse beat in comparison to the rest of us human beings. Or, says Bayer, let's say, imagine that humans don't live for 80 seconds or 80 years, but for 80,000 years, and that the pulse beat goes that much slower. Then the whole world would be different again. For example, the sun, while going at a certain speed for us, would then race across the sky like a fiery wind. It would not be the individual sun that would be distinguished, but it would race around like a reddish wheel. Plants would shoot up quickly and perish again at breakneck speed, and so on. Bayer puts this forward as a possible idea to show how the world view depends on the subjective constitution of the organism. As you can see, everything becomes shaky. When considering the kind of thinking that underlies such a notion as Flammarion's, Mr. Lumen, or Bayer's, one thing is important to note. Let us take Mr. Luhmann once more. It is assumed that Mr. Luhmann would be able to fly 400,000 kilometers per second, thus overtaking light and catching up with the later light images. But now take that which you can take as real when you go deeper into our spiritual scientific concepts. We can even disregard the coarser physical body altogether and go straight to the etheric body. Well, when we look at the etheric body, what is it? It is ether, light ether. It is itself weaving light. Keep that in mind, because what follows from that? It follows, after all, that if we move in space, we can, in the ultimate case, move with the speed inherent to light. So when someone says that a human being like Mr. Luhmann moves at a speed of 400,000 kilometers per second, we have to ask, I will even omit the physical body and just assume that an etheric body could travel out. How fast could it possibly move? Well, at most, at a speed of 300,000 kilometers per second, the speed of light. It cannot be said of the etheric body that it overtakes light, for it is itself moving light. So Mr. Luhmann cannot be woven from anything that exists in space. In other words, he is an unreal conception. He is purely a figment of the imagination. For the speed of the tangible or substantial in the world is immanent or inherent to it. It is intrinsic. It is its characteristic. We cannot rip it out. We cannot say we separate the speed from the thing, but it is a property of the thing. We cannot speak of a characteristic that lies separately outside the thing. So, we must also say with regard to Bayer's conceptions, the moment we understand that the speed of the pulse is part of what makes human beings human, we also understand that we cannot have any other speed than that of our pulse. We are human by having a certain speed of the pulse, and we cannot think of it as being arbitrary, because we would cease to be human if the pulse were, for example, 1,000 times faster than it is in reality. The speed belongs to our inherent nature. It is important to see how spiritual science leads to the essence of things and what that thinking leads to, which has developed up to and into our time without engaging with spiritual science. It leads to the formation of conceptions such as that of Mr. Luhmann or that of the pulse beating 1,000 times faster, which are utterly impossible or unreal. We calculate with fanciful concepts if we do not realize that time is a mere number. Thus, so-called rational mechanics has led to quite unreal concepts. Spiritual science leads us to say, what indeed is such a Mr. Luhmann who speeds along at 400,000 kilometers, whereas 300,000 is the most he, and there's a gap in the transcript. He is nothing other than the famous gentleman who pulls himself up by his own bootstraps. Spiritual science, then, from this point of view, exists to bring the thinking of the human being, which has fallen into the realm of fantasy, back to reality, not to lead it away from reality. You see, while spiritual science is accused of being fanciful, it is actually there to bring the fanciful ideas and concepts of physics back to reality. And it will be extremely important for healthy thinking that in the future the minds of children are really taught something like the two kinds of division, so that they do not calculate with all kinds of ambiguities, but with definite concepts. We cannot arrive at conceptions and concepts that have a meaning for reality in any other way than by really confronting reality, that is, by thinking with spiritual science, because that is where we arrive at real, not fanciful concepts. Before the theory of relativity, physics had Newton's conception that space is a void, a vessel, as it were, infinite or not, we will not examine that now, and that time flows along like a uniform stream. Objects are in space and processes take place in time, and depending on the time it takes an object to travel through a given space, a certain velocity is attributed to it. This conception is untrue, because it does not look at the essence of space and time, and thus separates velocity, which is actually an intrinsic property, into the two unreal concepts, space and time. Velocity is really the original thing, whereas physics always sees velocity as a function of space and time. But what belongs to things is their essence, and spiritual science shows that we must take certain paths in order not to arrive at fantasies about space and time, such as that of infinite space or that of time as a flowing stream, but to arrive at the genuine reality of velocity. The whole of mechanics, which we absorbed in our youth as something tremendously certain, as the most certain thing there is in science about mathematics, operates with quite vague concepts, because it does not know what the nature of velocity is, and does not know how to regard it as fundamental. Now, the impulse for the theory of relativity from Minkowski, Einstein, Planck, Poincaré, the late mathematician and physicist, and so on, came precisely because they could no longer come to terms with this childish Newtonian idea of empty space and regularly flowing time and things moving at a certain velocity. Certain experiments gave rise to concepts that did not coincide with what had been regarded as being of the utmost certainty. Now, I set out a concept for you here, recently, purely in connection with spiritual science, which may have come as a surprise to some. I set out the concept that it is not at all true to believe that the most important thing in the head is substance, matter, because precisely where we assume matter to be, it is hollow. And from the spiritual scientific point of view, we are all empty-headed. I use the comparison of the air bubbles in a bottle of sparkling water. There it is also the case that where we believe we perceive something real, actually there is nothing. The spiritual reality is all around, and there are holes in it everywhere. You can see them. Just as with sparkling water, you can only see the bubbles, which are air. You can't see the water. And if people think that there is something where I bump into the table, that is not true either, because there is actually nothing there. I bump into the cavity. And because there is nothing there, I can't go any further. We have arrived at this quite systematically on the basis of spiritual scientific premises. By another route, certain insightful and knowledgeable physicists have been driven to a similar view, because certain processes in nature are simply not compatible with the concepts of Newtonian mechanics, which are regarded as so certain. And these things include, for example, the processes connected with cathode rays, with which you are well acquainted, and which, as you know, can be observed in certain evacuated glass tubes. There you are dealing with something that has velocity as a moving thing, with electrons, metaphorically speaking, with flowing electricity. And through observation, through the experiment that physicists arrived at by observing cathode rays in the tube, which are flowing electricity, they have arrived at various curious ideas. And I would like to read to you one such conception. It is found in a lecture by Poincaré on the new mechanics. He starts out from the conceptions that arise from the cathode ray experiment, because this does not correspond with Newton's concept of velocity in particular. And then, after a rather confused train of thought, he feels compelled to make the following concession. In brackets, there's a gap in the transcript. And here the physicist feels moved to say the following, quote, "Matter has now become completely passive. The property of resisting the forces that seek to change its movement no longer attaches to it in the true sense of the word. When a cannonball moves at a great speed and thereby becomes the bearer of a living force, of a mighty energy which scatters death and destruction, it is no longer the iron molecules which form the seat of this energy, but this seat is to be sought in the ether which surrounds the molecules. It can almost be said that there is no more matter, there are only holes in the ether." Close quote. Well, what more do you want, my dear friends? Quote, "And to the extent that these holes seem to play an active role, it consists in that these holes cannot change their location without affecting the surrounding ether, which exerts a reaction against such changes, close quote. Matter is holes in the ether. So, physics, according to its present experience, is compelled to admit this. And following on from such experience, another physicist, Planck, spoke words that are most remarkable, namely the words stating, "We experienced in the 40s of the 19th century that Helmholtz approached a certain problem." It was not Helmholtz, but Julius Robert Mayer, but we do not want to get involved in this important question of priority now. In the way someone who now doesn't put the cart before the horse, but rather puts the horse before the cart. People had always said previously that the distribution of forces in space must be studied in a certain way. Helmholtz reversed the matter. He said that the universe must be studied in such a way that only the whole universe can be a perpetual motion machine, while the individual process in the universe can never be a perpetual motion machine. The people before had namely tried to explain the worldview entirely without perpetual motion. Now, however, Planck says that a similar process must occur with regard to the ether. There are countless theories about the ether, ranging from the conception that people had in the past, when they imagined the ether as diluted matter, to the conception of Lord Kelvin or J.J. Thomson, who imagined the ether as a rigid liquid. It should not be thought of as a liquid like water, of course. All intermediate stages are represented. And now Planck, as a physicist, says, physics will only become healthy when we start from the following major premise. No conception of the ether gives a tenable physics which attributes material properties to the ether. These are the words spoken by one of the most important physicists of our time. This means, then, that if the ether is to be a tenable basis of physics, only spiritual properties may be ascribed to it. And so it follows that today's physicists are urged to think of matter as wholes, and all around them the ether, which, however, must be imagined as having no material, but only spiritual properties. So, wholes surrounded by spiritual ether. That is what must be taken as a basis in order to arrive at a tenable physics. The ground is being prepared for that today. That exists. Now the question may be raised, well, so what has then happened to the possibility of justifying a materialistic view of the world if physicists say that matter consists of wholes and that the ether can only have spiritual properties? So you almost have to say, there is no more matter. There are only wholes in the spiritual ether, and matter cannot change its place without exerting an influence on the surrounding ether, a reaction in the spiritual ether. That is where physics has arrived. We will, however, need a keen logic. We'll not have to shy away from tackling such questions as to how the concept of velocity is really to be grasped, if it is not to contradict what comes to expression in the experiment. Take these things as something that ought to be said to prove that spiritual science, so reviled as unscientific, is infinitely more scientific in its foundations than that which is considered science today. For it goes to the heart of things, I might say, with the keenest logic. And this is what we must seek above all, a keen grasp of concepts, a precise grasp of what otherwise confronts us as a vagueness in the world. And that is the end of the last lecture, Lecture 11, of the book, The Value of Thinking for a Cognition that Satisfies the Human Being, Collected Works, Volume 164.